Okay, so our group are going to present about corrosion. So of course, this is the topic that our group got it. So we are going to present about it. So first thing first, let me present about what is corrosion. Corrosion is a natural process that causes the deterioration of material, particularly metal, due to chemical reaction with the environment. This process typically involves the degradation of a metal as it reacts with substances such as oxygen, water, acid, or other chemicals present in its surrounding. As you can see on the picture in the bottom left, it is a quick time lapse of the corrosion as you can see on the iron. And on the bottom picture, it is how it process in chemical term. And on the right picture is the completion of it.
For the history part,
The hell's wrong history.
early observations. Humans have been familiar with corrosion since ancient times, as evidenced by the deterioration of metals like iron when exposed to moisture or acidic substances. The early civilizations observed the effects of corrosion on tools, weapons, and structures, though they lacked a scientific understanding of the underlying chemical processes. And next, development of theories. The systematic study of corrosion began in the 18th and 19th centuries with the emergence of chemistry as a scientific discipline. And Anton Lavoisier, known as the father of modern chemistry, made significant contribution to understanding oxidation and reduction reactions, laying the groundwork for later corrosion theories.
Electrochemical theory. In the early 19th century, Humphrey Davy and Michael Faraday conducted experiments that led to the development of electrochemistry. Faraday worked on the electrochemical reactions, provided insights into the mechanism of corrosion, particularly the role of electron transfer in oxidation reduction reactions.
Whoop! The role of water and electrolytes. Researchers in the 19th and early 20th centuries, such as Friedrich Paschen and Wilhelm Oswald, investigated the influence of water and electrolytes on corrosion processes. They identified the importance of moisture and dissolved ions in accelerating metal degradation. Modern corrosion science. Corrosion research continued to advance throughout the 20th century, with contributions from scientists and engineers in various fields, including metallurgy, chemistry, and materials science. The development of sophisticated analytical techniques such as scanning electron microscopy and electrochemical impedance spectroscopy has allowed for a more detailed understanding of corrosion processes at the molecular level.
Next up is the type of corrosion that we are going to be presenting. The first one is the uniform one. Like the name suggests, the entire surface is the same. It corrodes all at once. So you are going to see an even surface that are all corroded. Next is the galvanic corrosion. The galvanic corrosion occurs only on the metal that are more reactive than the other one. This is also used by the sacrificial method to actually prevent some metal from corroding, such as some screw and a steel nut that you can see on the top right hand corner. Next is the pitting corrosion. The pitting corrosion occurs locally, meaning that the damage caused by the environment causes a small pit or a small crater within the metal that results in a chain reaction that causes it to rust and expand over time. Next up is the crevices corrosion. The crevices corrosion, like the name suggests, only occurs on some part of the metal due to the environmental localization. For example, you can see like a pole on the streets, for example. At the bottom where people or rain can actually interact with the metal, you will see a lot of rust. But on the top, on the very tippity top, there's not much happening there, so it's pretty clean. Lastly is stress corrosion. Now, when metal undergoes stress, there will be microscopic space between each atoms, which then can interact with the environment and causes rust. And when these happens, it occurs in a space that is filled with rust, and when the stress actually gets back to normal, it kind of makes the entire structure fall apart. And this is a problem in many industry and facility, and why metals in some places need to be replaced because of this type of corrosion.
Relation between corrosion and society. Environment impact. Corrosion can have environmental consequences, especially in industry that can release hazardous substances to environment. Example: corrosion in storage tank can release toxic chemical or pollutant in soil, water, or air. Economic part. Corrosion represents a substantial economic burden on society. The direct costs associated with repairing or replacing corroded infrastructure, machinery, and equipment are substantial. Additionally, indirect costs lead to downtime, loss of productivity, and environment cleanup, further exacerbate the economic impact. Public safety. Corrosion-related failure can endanger public safety. For example, corrosion-induced failure in pipeline can lead the leak, spill, and accident posing risk to human health. And corrosion-related failure in transportation. Infrastructure such as bridge or tunnel can also result accident and loss of life.
After we have talked about the relation between corrosion and society, next is the issue that it will cause to society. First one is infrastructure degradation. Corrosion can compromise the integrity of critical infrastructure such as bridges, pipelines, and buildings and transportation systems. This degradation can lead to safety hazards, service disruption, and costly repairs or replacement. For example, the pipeline that was buried under the ground, it will be very hard and takes a lot of time to fix it before it can serve the people again. Next is resource consumption. Corrosion accelerates the consumption of resources by necessitating more frequently repairs, replacement, and maintenance activities. This leads to increased energy consumption, raw material usage, and waste generation, exacerbating environmental impact and resource depletion, which will cause economic impact. Corrosion represents a significant economic burden, resulting in direct costs associated with repairing or replacing corroded assets and indirect costs such as downtime, loss of productivity, and environmental cleanup. This expense can strain budgets and hinder economic development.
Next up, we're going to talk about the solution. Incorporating corrosion-resistant design features such as proper drainage, ventilation, and material selection can help mitigate corrosion damage. Designing structures to minimize crevices, area of stagnant water, and galvanic corrosion potential can also reduce susceptibility to corrosions. Next, we're going to talk about the protective coatings. Applying protective coatings such as paints, primers, epoxy coating can create a barrier between the metal surface and corrosive environment, preventing direct contact and inhibiting corrosion. Proper surface preparation and application techniques are essential for the effectiveness of coatings. The use of corrosion-resistant materials. Selecting materials that are inherently resistant to corrosion can significantly reduce the risk of degradation. Stainless steel, aluminum alloys, fiberglass, and certain polymers are examples of corrosion-resistant material suitable for various applications. Thank you for listening to our presentation. See you again next time.